Welcome. So in this lesson, we're going to be going through the graph of sine and cosine. We're going to begin by filling out this table of values for the graph of sine, and then we will plot the graph, and then we'll do the same thing for the graph of cos. To help us through this first page, I'm just going to go through this presentation right here, and you can follow along with me. So the graphs of sine and cosine. Let's begin. So here we have sine of x, and we're very familiar with the sine of x. We've seen it in our previous lessons. But as you can see here, we have y equals the sine of x. So that means we're going to be graphing this right here. Here we have all the x values that we're going to be putting into our x position here. And then we're going to be figuring out what our y output is going to be. So if x is equal to 0, that means I'm going to get sine of 0. And we know that I'm going to get y being equal to 0 because sine of 0 is just 0. So I want you to put a 0 there. And I also want you to mark that dot right there. So this point, 0, 0 is our coordinates. There it's going to be. If I now let x equal pi on 2, well, sine of pi on 2 is 1. So when x is pi on 2, y equals 1, so we put a dot there. And then we just continue. When x is going to be equal to pi, sine of pi is going to be 0. So when x is equal to pi, our y is going to be equal to 0. And then we just keep on going. Sine of 3 pi on 2 is going to be -1. Sine of 2 pi is going to be 0. We get all those dots, and now we're just going to connect them all together. And we're going to end up with this shape right here. Now, it's very important that you memorize this shape. This has to be burned into your brain. This is what sine looks like. Then we do the same for our negative values there. We plot them, we draw them in like that. So this extends backwards as well, and it goes on for infinity, forwards and backwards. So it's really important that you know what the sine graph looks like. All right, so pause the video if need be to fill out this table and to make your plots and to draw it. All right, let's now move on to our next graph, which is cos. So the same thing again, we're just going to be subbing in our x values. Cos of 0 is 1 in this case. So we put a 1 there, we put a dot there. Cos of pi on 2 is going to be 0. Cos of pi is going to be -1. Sine of 3 pi on 2 is going to be 0. And then cos of 2 pi is going to be 1. And then we're going to get that shape right there. And again, it's going to be very important that you just memorize this shape. This is very important that you know this shape. This shape is cos. Then we do the same for our negative values. We plot them. And then once we've done that, we just realize that this thing goes on forever, but forwards and backwards. So again, pause the video and make sure that you've written all that down. Once you've done all that writing, I want you to put your pen down, and I'm just going to talk through some notes for you. And then once I finish talking, we'll then go through the next page together. But for now, I just want you to put your pen down, and I just want you to watch me talk about some key ideas, which are very important. So let's just stick with this graph for the time being. Let's talk about our first idea, which is the amplitude. So what is the amplitude? The distance between the mean position and the maximum position is the amplitude. So if we were to visualize that, it's just this distance right here, which is of course going to be the same as this distance here. So our mean value is just the middle of our graph, and then it's just going all the way to the top. So it's quite clear that in this case, our amplitude is going to be 1. So we just say our amplitude is equal to 1. The other idea that we need to discuss is that of the period. So the interval between the repetitions is called the period. So if we can just visualize this for a moment, as you can see here, it goes up, down, it just goes on forever. But one interval would just be, it starts here, it goes up, it goes down, and now I'm back to the same position. It's made one full cycle. So it's really important that we realize that it's made one full cycle to get back there. So what's the distance to make one full cycle? Well, it's 2 pi. From 0 to 2 pi, that's one full cycle, and that's what we call a period. So the period is equal to 2 pi because that's how long it takes me to do one interval. So the interval between the repetitions is called the period. Okay, hopefully both of those make sense. And now I want to connect these ideas of amplitude and the period to something that we have already seen, and that is transformations. So let's just kind of give ourselves a bit of a refresher on transformations with a graph that we are familiar with. So this is just y equals the square root of x. Now, if I was to put a number in front of it, what would this do? Well, if it's 2 times the square root of x, we know that this 2 is just causing a dilation of a factor of 2 from the x-axis. And if we were to have this graph, when we would have 5 times x, underneath the square root here, we know that this would cause a dilation of a factor of 1/5 from the y-axis. So this is something that we've seen before and we're comfortable with. When the number is on the outside, we know it's a dilation from the x-axis. When the number is in the inside, we know that it's the reciprocal and it's from the y-axis. We know this. Well, these principles hold true for circular functions. So for instance, when I'm dealing with y equals sine of x, if I have a number out the front, I know that this 2 is going to cause a dilation of a factor of 2 from the x, just as it did over here. And it's this idea that is going to be linked to the idea of amplitude. And then when we have a number next to our x, this is when we're going to have a dilation of a factor of 1/5 from the y-axis, just as we did over here. And it's this idea that is linked to the period. So let's now further discuss this and further just cement these ideas in our head. So the amplitude is the dilation of a factor a from the x-axis, and the a is just the number out the front. And what makes the amplitude so easy is you can read off the amplitude immediately. It's literally just the number in front. It's just going to be a. The amplitude is just a, just the number in front. How easy is that? And we know that it represents the dilation from the x-axis. The period, on the other hand, is a bit more confusing. And the reason why it's confusing is because we need to remember that the period isn't just b, because it's the dilation of the reciprocal of b from the y-axis. That makes things a little bit more tricky, and I'm going to talk about this very soon. But for now, let's just talk about the amplitude because it's a bit easier and we'll just ease ourselves in. But then I want to talk about this because, as you can see, it's more complicated than simply just saying the period is b. The period is not just b here, there's more to it, and we have to utilize this formula here. Okay, but let's first just take a deep breath and let's go through something quite simple. And that is y equals sine of x. We're going to be treating this as our parent function. We've seen it before, we've graphed it, we plotted it just a few seconds ago. We know it looks like this. So therefore we know that the amplitude is 1, which means this is 1 here from there to there. And the period is 2 pi, meaning I go up, I go down, I go up, 1 full cycle is 2 pi. That's what we know. Well, if we know this, what happens if we transform this graph? So now we have y equals 3 sine of x. Well, this 3 is telling me that I'm having a dilation of 3 from the x-axis. And we can also say, based on this, that the amplitude is just going to be 3, because we know it's just the number in front. So the amplitude is very easy just to read immediately. The amplitude is just going to be 3. Easy peasy. The period isn't going to change because we haven't altered our x here. So the period is just going to remain at 2 pi. We'll talk more about period soon. Let's just focus on the amplitude here. So as I said before, this 3 means we have a dilation by a factor of 3 from the x-axis. So if I go to this point right here, it means this point right here is going to be dilated by a factor of 3 from the x-axis. So that means it's now going to be up here. So remember, when we're dilating from the x-axis, it changes our y value. So I went 1 times 3 is 3. And then we would do this for all our points. So this point here is just 0, so it just stays where it is. But then this point here would dilate from the x-axis by a factor of 3, which means it would now come down here, as you can see. And it was -1 times 3, which brings us there. So this blue graph, after we have performed the transformation, is now dilated away from the x-axis, and that's what it looks like. So hopefully you get a good understanding of what the amplitude is. Amplitude is linked. The amplitude is the dilation from the x-axis. So as you can see there, it's 3. All right, now we come to the more difficult idea. The more difficult idea is the period, and we need to specifically hone in on this right here, this 2 pi over b. This is the period, 2 pi over b. So we get the b value, which is the number in front of x, and we go 2 pi over the b. Now, the reason why we're using 2 pi is because we know with our parent graph right here, the period is going to be 2 pi. So now that this b is going to change our dilation from the y-axis, we need to think about it in terms of that 2 pi that we started with. So let's now transform this graph into this. So our amplitude is the same. Our amplitude is 3, easy peasy. But now we have this 2, which tells us there's going to be a dilation of a half from the y-axis. So we're going to be squashing it towards the y-axis. Now, how can we utilize this right here? As I said before, we know that currently the period is 2 pi, right? Well, if I'm going to dilate it by a factor of a half, I'm going to take the current period, 2 pi, and times it by 1/2. And that's the same thing as simply going 2 pi over 2. And that is what the period is, 2 pi over 2. So even though I'm writing this here. I'm just showing you this for you to link this reciprocal with it. But you just use this. You just go 2 pi over whatever b is. And in this case, b is 2. So it's 2 pi over 2, which is just pi. So that means I'm taking my points and I'm bringing them closer to my y. So 2 pi is now going to become pi. Pi on 2 is now going to become pi on 4. And I really want you to take note of the fact that we're squashing it towards the y-axis because we're dilating it by 1/2. So we took that initial 2 pi and we times it by 1 over what's in front of our x. And in this case, it was 2. That's how we're approaching it. That's what the period is. All right, hopefully that makes sense. This little table can be found in your textbook if you want to refer to that later. But right now, let's continue going on with our notes and just really practice this skill. So we've filled out this and we've filled out this. So let's now just read over once again what the period and amplitude are. So the period. The interval between the repetitions is called the period. A function which repeats itself regularly is a periodic function. The period of y equals sine of x is 2 pi. The amplitude. The distance between the mean position and the maximum position is called the amplitude. The amplitude of y equals sine of x is 1, and you can see that there. I've also put in the range here. So remember, the range is just the range of your y values. So it's from -1 to 1. And remember those inclusive brackets there. So obviously the range is linked to your amplitude there, and we'll be seeing that more soon. Then we've just got down these general rules that you're going to use to find the period and the amplitude. So as you can see here, what you need to take note of is we have sine of x, but then we have an a in front and then an n next to our x, and the same thing here. To find the period, you go 2 pi over n, and remember that n is here, it's here. The amplitude is far easier. It's just whatever is in front of the function. Easy peasy. Remember that a dilation of 1 over n for the y-axis, so that's what we were talking about before in that presentation. Note, if n is a negative value, the curve is reflected in the y-axis. So I've put this here, but I'm going to have another part of this lesson talking all about reflection, so don't freak out too much about that. And then for our amplitude, it's a dilation of a from the x-axis. Note, if a is a negative value, the curve is reflected in the x-axis. Don't freak out too much about reflections. We'll talk about more about that soon in a different part. All right, let's now go through some examples here. It says, for the following, give a sequence of transformation which takes the graph of y equals sine of x to the graph of y equals g of x. So we're starting with this, and we just need to list the transformations which have occurred. This 3 tells me that there has been a dilation of a factor of 3 from the x-axis. And you might want to put in brackets here, amplitude equals 3. Also, this 2 tells me that there is a dilation of a factor of, now this is important, it's the reciprocal of that, so it's going to be a half from the y-axis. And in brackets, can you put in that the period is 2 pi over 2, which is just pi. So again, you need to be able to link in your head the idea of dilation from the x-axis with the amplitude, dilation from the y-axis with period. Let's now go through some more examples here. This is asking us to state the amplitude, the period, and the range for these. To find the amplitude, it's really easy. You're literally just looking for the number in front. It's going to be 5. The period, what you're going to do is you're going to say it's 2 pi over whatever is in front of the x. So in this case, it's going to be 4. You then simplify. This is pi on 2. That's going to be the period. Finally, the range. What the range is going to be is simply -5 to 5. Just so we can, I won't do this for all of them, but just for this one, let me just give this a really rough sketch. So if we think of sine for a moment, sine goes up, it goes down, it goes up again. If our amplitude is 5, this goes up 5, it's going down to -5, and that's how we're getting the range there. Can I just draw that a bit more neatly? And you might want to write that down too, just so you feel comfortable with the idea of the range. So the range is just the range of my y values, just like that. Remember the square brackets because we're including them. You might like to pause the video to see if you can answer the next ones for yourself. We're going to be using the same ideas. All right, let's go through the next one. Now it's important here to realize that I have -8, but my amplitude is never going to take into consideration the negative. It's just going to be 8. So that's important, very important that we don't care about the negative there when stating our amplitude. The period. The period here is going to be 2 pi over. Now what's in front of my x here? Well, what's in front of my x here? This is 1 over 4x. Same thing. So I'm going to put 1 over 4 here, and that's going to be 8 pi. And then next we have our range. Our range is easy. We're going to be going down -8. We're going up 8. That's what our answer is going to be. So those are going to be our answer. I want to stress again that our amplitude is not negative, even when we've got a negative there. Let's go on to our next one now. We have this. My amplitude is just going to be 1 on 4. Again, even though it's a negative here, our amplitude is not going to put in that negative. Then the period is going to be 2 pi over. Now this right here, again, similar thing. This is 3 over 2x. So the number in front of x is 3 over 2. So we put 3 over 2 into this. And this is going to end up being 4 pi on 3. What I remember is you just take this one and you multiply it with the top one. And then our range is going to be -1 on 4 to 1 on 4. And those are our answers. 1 on 4 is our amplitude, 4 pi on 3 here, and then -1/4 to 1/4. All right, hopefully you found this useful. There's a lot of ideas here, but I just hope that you have a really good grasp of this. If you have any further questions, make sure you find me. This is part 1 of this lesson. I'll have a few more parts going through some more examples so you become really comfortable with drawing these graphs. I'll see you in those other parts.